Good morning. It's July 27th, and this is your daily brief in science. Here's everything you need to know. A 3-astronaut U.S.-Russian crew has returned to Kazakhstan, completing a 241-day stay on the International Space Station aboard Soyuz MS-28 and marking the end of Expedition 74. The mission underscored ongoing cooperation between the United States and Russia in space exploration through joint ISS crew rotations and shared spacecraft partnerships. Earlier in July, Expedition 75 launched from Baikonur, highlighting the multinational presence on the ISS with NASA's Anil Menon, alongside Roscosmos cosmonauts Pyotr Dubrov and Anna Kakina. Reuters reported the details, with Anton Kolodyazhny as the journalist and Joe Bavier as editor. The article notes that Williams, who has a background in imaging and cancer treatment technologies, contributed to the mission through scientific studies and demonstrations, including cancer research and in space manufacturing for high-performance computing and electronics. Williams is described as an Eagle Scout, private pilot, and former volunteer firefighter and EMT, born in New York City with Potomac, Maryland, listed as hometown. The ISS return confirms mission duration and landing details, with successful re-entry and recovery operations. NASA released landing footage on X and posted a 2-hour YouTube video covering the mission's landing coverage. The broader article includes local briefs and video segments from KOTA Territory News, covering wildfire preparedness, rally logistics, indictments, ambulance coverage, mobile STEM education, and a political runoff update, forming a wider news roundup. The piece centers on the ISS crew return while situating it within ongoing international collaboration in space exploration. The story reflects the official reporting standards of Handelsblatt and Reuters coverage, presenting the facts straight and without opinion. A potential closure of Jodrell Bank Observatory in Cheshire hinges on UK R1 funding cuts, risking all observations from April 2028 unless new funding is found. The move comes as UKRY withdraws support for the e-Minerva network when the current agreement ends in March 2028, threatening the UK's National Radio Astronomy Facility. Scientists, including Prof. Catherine Haymans, say the decision would devastate the observatory's research capabilities and its role in ongoing radio astronomy. Beyond science, the site holds cultural and educational significance, with UNESCO designation and connections to science fiction, Cold War-era contributions, and a long history of public engagement. Historically central to UK radio astronomy, the Lovell Telescope and e-Minerva have studied distant galaxies, star and planet formation, dark matter, and dark energy, and trained generations of astronomers. The Lovell Telescope is among the largest steerable radio telescopes, and with a Minerva it provides high-resolution observations that compete with the Hubble Space Telescope in certain studies. Industry observers point to tensions between funding limits and sustaining world-leading research infrastructure, warning of broader impacts on UK astronomy and discovery science. The announcement comes as international developments in radio astronomy accelerate, including the Square Kilometre Array, raising concerns the UK could fall behind in a new era of discovery. STFC says the withdrawal follows a rigorous prioritization process to allocate funding to areas with greatest long-term capability and value, focusing on future radio astronomy facilities. UKRY maintains the aim of protecting core discovery research while aiming for a sustainable position by 2029/30, prioritizing investments with higher long-term impact. Reactions from scientists and union bodies emphasize that the cuts threaten the UK's science reputation and the future of physics facilities and careers. Experts describe the decision as short-sighted both scientifically and economically, warning it could impede training and the country's competitiveness in radio astronomy. Two distinct neural circuits control how habits form and how they are carried out. A pathway from the anterior cingulate cortex to the retrosplenial cortex helps determine if a behavior becomes a habit, with its connections weakening during the transition. A separate circuit from the lateral orbitofrontal cortex to the central striatum governs how strongly that habit is executed. Researchers bidirectionally manipulated these pathways to test causality, showing that stimulating or inhibiting them can induce habit formation or adjust the magnitude of habitual execution on demand. The results revealed dissociable roles in decision-making strategy versus execution, enabling selective promotion of habit formation or tuning of execution levels. The study is open access in Nature Communications and involves Kyoto University and a collaboration of neuroscience-focused teams. These findings point to potential applications for cultivating beneficial habits while reducing problematic ones linked to obsessive-compulsive patterns. Scientists also aim to understand why individuals differ in habit strength to better promote beneficial routines and curb compulsive tendencies. The paper, titled Dissociable Roles of Prefrontal Plasticity in Decision-Making Strategy and Execution of Habitual Behavior, was published July 27, 2026, DOI 10.10387/S41467-026-75706-1. The work contributes to a 2026 Nature Communications publication that maps how prefrontal plasticity supports distinct aspects of habit formation and execution. Overall, habit formation appears to be a dual process, not just repetition, with substantial individual differences in how often and how intensely people perform habitual actions. Findings highlight targeted therapies that could down-regulate hyperactive habit execution via the LOFC to central striatum pathway without harming goal-directed learning, offering potential avenues for OCD and addiction treatments. A new mouse study shows that inherited genetic background shapes cancer development after the same DNA-damaging exposure, linking germline variation to tumor evolution. Researchers used 4 genetically diverse mouse strains and a controlled liver carcinogen to isolate genetic background effects from environment. All tumors activated the MAP signaling pathway, but the driver mutations and evolutionary trajectories varied by genetic background. Some lineages showed a higher tendency for whole genome duplication, a change that can accelerate tumor evolution by adding genetic material for selection. The study demonstrates that inherited genetics influence both mutation processes and pathway choices, suggesting DNA-damaging therapies may have varying effectiveness across individuals beyond standard clinical factors. Key researchers include Duncan Odom, Dr. Sarah Aitken, and Professor Martin Taylor, with international collaboration across Europe and the United States. The work was primarily conducted at the C-Ruck Cambridge Institute and published in Nature, with funders Cancer Research UK, the Medical Research Council, the European Research Council, and Wellcome supporting the research. The findings imply that cancer screening, prevention, and precision medicine should account for population diversity and individual genetic backgrounds when assessing risk and planning treatment. Incorporating population diversity and inherited genomic context could improve prognostic power and therapy targeting in prevention and precision oncology. Overall, cancer care may require precision medicine that accounts for population diversity and each person's genetic background across prevention, screening, and treatment strategies. A new genome study on Guam's invasive brown tree snakes finds substantial hidden genetic diversity, especially in structural variants, concentrated in immune and smell-related genes that may drive adaptive traits like enhanced olfaction and immunity. Researchers from the University at Buffalo, in collaboration with USGS, published their results in Science Advances. Long-read sequencing revealed more than 19,000 structural variants, indicating extensive genetic rearrangements not detected by standard methods. There is uncertainty whether these structural variants existed before the invasion or arose afterward, underscoring the need to compare with snakes from the native range. Despite extreme inbreeding across the genome, the Guam population thrives across the island, suggesting a severe bottleneck during invasion, yet notable genetic resilience. Structural variants cluster in gene promoters and in immune and olfactory gene families, implying these regions preserve diversity despite inbreeding. The findings prompt a rethink of conservation genetics for endangered species, highlighting hidden structural variation as a crucial source of diversity not captured by traditional measures. Beyond Guam, the study stresses the value of long-read sequencing to understand adaptation and resilience in small, inbred populations and to inform conservation strategies. Science Advances shows that invasive brown tree snakes in Guam maintain substantial genetic diversity despite a small founding population, challenging bottleneck expectations. This diversity may have contributed to very high densities and sustained adaptability in the island environment, with diverse immune and olfactory genes potentially supporting ongoing adaptability and possibly influencing mate choice and immune compatibility among potential mates. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.